And I would like to present here my presentation about my project report for CS5200 course in spring 2024. The name of the project is Artificial Intelligence Realization of the Python Game. Here I go. First of all, the brief content of the report will be, I will start with motivation, then short game description will follow, then I will dive into details on computer realization, then present experimental results, and conclusion will follow, and the live demonstration of the game. So, as name game, it is well known. It is about a snake which is moving on a flat playing field, hunting for apples, trying to survive. The simplest version of this game existed for a long time, and lots of updated versions are currently available. So possible extensions of this game are you can introduce some obstacles, kinds of walls to the game, or you can make it able for more players to play this game simultaneously. This game fits perfectly in this project since it is easy to program and can be used as playing field for artificial intelligent agents. So I decided to work with this idea. The game description, if you can see, the game fits perfectly well in peace ideology. The performance of the program will be to maximize lifetime or length weight of the agent. Environment consists of coordinates of all food chunks, obstacles, or other players. The actuators in this field will be output part of the program interface that helps you to change the movement directions, and sensor will be input part of the program interface that helps you to find out position of an interesting parts of the surrounding environment. The properties of the system are the following. First of all, it is observable or partially observable since some agents can use only part of the information. It is deterministic mainly since we know for sure what will happen on each step. The only randomness can come from movement of other players. It is sequential since one game doesn't depend on the previous games. It is dynamic since all snakes are moving, apples disappear, and so on. And of course, it is discrete since each game goes in steps, the field is discrete, and so on. And it is a multi-agent game since different types of players can participate in the game simultaneously. So let me talk a little bit about the realization of the game. There are four main components that are in play. This is game, agent, action, and path. The game agent, it is actually in some sense main class of the game, and the property that it contains are board, which is represented actually as a rectangle array, then list of apples and list of agents that are currently presented in the game. Things that this class can do are, first of all, it should be able to display all objects of the game and the board itself. Then it will be able to provide information to the agent, and the main part, it orchestrates all the events, meaning that it asks agent for next action, perform this action, and finally check the current situation for collisions and remove dead agents from the game. There is also some technical stuff. Probably the other very important class for the game is agent. This is implementation of various snake bots. The first class, abstract class, is agent. It is actually very simple. The only property that it contains, it is a game that will be used to ask the game for surroundings. And the only method that it has, it should be able to return next action, which is directional next desired move. This class has a lot of children. For example, agent up and agent down classes, they always move up and down. Human agent, it is a snake that follow the keyboard control commands. Here is an example how it goes. Then we have random agent that makes a random move without paying any attention to surrounding apples, only trying to survive. Next one is greedy agent, which follow the shortest path to the nearest apple. You can see it here. The next one is search agent. Now it goes in the way it hunts to the nearest apple, but planning all the way to this apple beforehand using the deep first search algorithm. And the final agent that we have, it is a star agent, which searches again the shortest path to the nearby apple, but using a star algorithm. So once again, to remind, these four agents, they try to survive since they redo all planning when about to hit an obstacle. So the next class is action, which is simply enumeration of all possible actions, up, down, left and right. And final class, path, it actually it is a realization of the agent's plan, so it holds starting point and list of actions, and can report ending point and cost, which is length of the path, and so on. So installation of the game is pretty simple. It is Python project, so first thing that you should do, you install virtual environment, activate it, and install all required libraries, and then start the interactive run. So here is one example of this interactive run. So during the game you can modify game behavior using the following keys. For example, you can quit the game, pause it, increase or decrease game speed, show the paths of the agents, of the playing agents, and add a random agent at random position. You can also modify the starting configuration of the game using these command line interface keys. You can specify the layout of the starting maze by selecting the board file. You can change the game speed by showing out the number of frames per second. You can specify a list of agents. I will show you later how it goes. You can also specify seed number of apples to produce, size of the cell in pixels, or you can run in quiet mode. The last option, it is very important. I will talk about it now. So in quiet mode, there is no graphic user interface windows. It is not opened. There is only text only. For example, let me start the game with this command. As you can see, it goes in quiet mode with only two agents, actually two A stars, with the goal following seed number. And the output of the game will be the following text that shows us that game two A star agents were added, and first of them died and length equal to 20 at time tick 117. The second guy died a little bit later. Okay, so with this approach makes us able to make some simulations, and to make them more easy, more automatic, I have created the following shell script, which actually what it does, it for 100 times it selects randomly the place configuration, and then for each configuration for 100 times it makes 100 simulations and saves all the result in the corresponding text files, which are distributed into corresponding folders. So these I decided to make two types of experiments. First, one-player game, the second one, two-player game. Talking about one-player game, as you can see, I have created about thousands of simulations for each game type, and here are the results. Briefly, results are the following. If we are considering time metrics, living time as a matrix, random agent is best for survival, which is not surprising since the only top goal that this agent pursues is survival. Greedy agent is the worst, and the reason is that it becomes longer since it hunts for apples, but it is too stupid to avoid obstacles for a long time. And finally, our two search agents, deep depth first search and A star, are similar, then could be long and then can escape the obstacles. If the length is considered as a metric, we can see that our search agents are similar. The winners show best length, greedy agent is again in between, and the random agent is the worst. Okay, the reason is very simple, since hunting for apples it is not considered as the goal of this agent. We can show the same results, see the same results if we consider scatter plot of time and length. As you can see, all search agents, actually including the greedy one, show almost the same pattern, while the random search agent is completely off the line. Now I have also prepared two-player games. So now in this table you can see statistics that I collected for each simulation. And for each of the simulations, I have collected such information as the length of the object, time that it used, and so on. So it turns out that comparing one-player and two-player performances, it turns out, first of all, that random agent lives longer in both variants, but it is the shortest. Here, for example, both in one game and two game, random agent lives for more than 600 ticks, but the length of this agent in both cases it is less than 10. Then greedy agent is in between, and deep depth first search and star agents are the longest one, comparable, but a star is slightly better. Then it turns out that both lifetime and length of two-player game are usually smaller than one-player game. It also makes sense, since in two-player game there are more possibilities to die. And then, interestingly, in two-player game, second player is usually in better position than the first one. You see, for example, here in the time of the second player, it is slightly when a random agent is the first player in two-player game, its time is slightly smaller than when it is second agent. Okay, and if we now compare winning probabilities of different agents in a two-player game, we can see the results here. If living time is considered as a metric, you can easily see that random agent is a star. It wins in almost all the games. A greedy agent cannot beat anyone, and again, search agents are good against greedy, not very good against random agent. And if you see on the numbers on the diagonal, you can see that first player loses more often. All the probabilities are below 50%. Situation sometimes changes completely if length is considered as winning metric, since in this case a random agent is a loser. You can see it here. And winners are very good, very good winners are search agents, deep first search and A star agent. Greedy one can beat only random. And again, the first player usually is in slightly worse position than the second one. And now let me show you some conclusion. First of all, during the implementation of this project, I created Python program for Python game simulation, and this program is the extension of classical snake game. In addition, I have added obstacles plus multiple players. Different kinds of agents were tested, stupid ones up, down, random, human, and some kind of search computer agents, greedy, depth first search agent, and a star. Number of computer simulations were performed for one-player game and two-player game, and the results of the tournament are the following. First of all, random agent wins when lifetime is critical. A star agent wins when the length of the snake is critical. Both of the results are actually expectable, since random agent doesn't hunt for apples. The goal of this agent is not to be long, but to survive for a longer time. While A star agent, the goal of this agent is to become as long as it can, and the A star search algorithm is efficient. So thank you very much for your attention and enjoy the game example. Thank you. Let me show you some example of the game. I will start with the default configuration, meaning that there will be, okay, let me be 10 apples, very slow game at the beginning. Then we will have full agents: human, random, greedy, then depth, first search agent, and S-star agent. Here it is it. So let me name the players. This is human, this is random ban, greedy, search, and A-star. Now let us try to play the game. So, as you can see, first of all, human agent, which is 0, can do whatever I want. I will first hunt for this apple, then for this one, then for this one. Random agent here, it does actually nothing but going in that or this direction, sometimes accidentally eating the apple and becoming larger. The greedy agent, this one, it goes to the nearest apple by the first best shortest direction, shortest route. Okay, then depth agent, here it is. It also do the same thing, but it takes into account all obstacles and other agents. And finally, A star, it also performs a search to find the apple path to nearest agent, but it uses A star search but not depth first search algorithm. So let me make game a little bit slower. Here it is, and see who will die first. As you can see, in this case, the greedy agent was dead first, which makes sense. It is a stupid one. And as expected, random agent is the shortest one. And now the first agent died. And so now we have random agent, which are the longest, so we'll leave one, that's acceptable. Okay, now I died, a star agent died, and the longest living guy is a random agent. Okay, now it will be very dull, so I quit the game. Thank you.